All right, today we've got a story that sounds like something out of science fiction, or maybe even alchemy. We're talking about taking one of the most disgusting pollutants on the planet and turning it into a high-tech power source. Seriously, let's dive in.
But before we get into the how, I want to ask you something. Just take a guess. What do you think is the single most littered item on the entire planet?
Yep, if you were thinking cigarette butts, you are absolutely right. But here's the kicker, the really amazing part of this story. Scientists have just found a way to transform that exact toxic trash into a powerful, high-tech energy device. Okay, so to really appreciate how big of a deal this is, we've got to first understand the sheer scale of the problem we're talking about. Just look at this number, 4.5 trillion. That's how many cigarette filters are estimated to be thrown out every single year. I mean, that's just a mind-boggling amount of pollution coming from just this one thing. So, what are these things even made of? Because, they're not just paper and leftover tobacco. Nope. They're mostly a plastic called cellulose acetate, and they're soaked in a nasty cocktail of toxic chemicals. We're talking arsenic, benzene, heavy metals. And the worst part, they stick around for decades. And when they finally start to break down, they just become tiny little microplastics. In the paper this is all based on, the scientists actually call them plastic time bombs. And that's a perfect description, right? It just perfectly captures how these tiny bits of plastic can work their way into the cells and tissues of, well, pretty much everything, wildlife and, yeah, us too. But what if we could diffuse those little time bombs? What if we could actually turn all that trash into treasure? That is exactly what this research is all about. And that treasure is something called a supercapacitor. So what is that? Well, think of it like a hybrid energy device. You know how a normal battery is like a marathon runner? It's got great endurance, but it's kind of slow to charge. And then a capacitor is like a sprinter, an incredible burst of speed, but it's over in a flash. A supercapacitor, well, it's kind of the best of both. It can charge and discharge super fast, over and over and over again. So this all led the scientists to this one huge question. Could we actually take all this toxic, everywhere you look trash and turn it into a critical piece of one of these advanced energy devices? Which, of course, brings us to the really cool part, the how. How on earth do they actually cook up this solution? Okay, so this diagram from the study pretty much shows the whole journey. You see on the left, you've got the raw material, nasty, dirty cigarette filters straight from the street. And then if you follow it all the way to the right, boom, a finished supercapacitor cell. It's an absolutely wild transformation. Let's break that down into 4 simple steps. First, pretty obvious, they collect and clean the filters. But then comes the real magic. It's a process called pyrolysis. Basically, they cook the clean filters at a scorching 800 degrees Celsius, but, and this is key, with no oxygen. This intense heat completely transforms the plastic, breaking it down and rearranging the carbon atoms into this amazing new stuff, a super porous, really conductive carbon nanomaterial. After that, they just have to purify the black powder that's left over and mix it into a paste to make the electrodes, the parts that actually store the energy. But, making the material is just one part of the puzzle. The real question is, does it actually work? And how well does it work? Now, the team knew that a supercapacitor's performance really depends on the electrolyte. That's the chemical soup inside that lets the charge move around. So to find the absolute best combination, they built and tested 4 different versions. And here are the results. This table lays it all out, comparing the 4 different cells they built. You can see they tried 2 different strengths of sulfuric acid, that's the H2SO4, and 2 of potassium hydroxide, the KOH. Now just look at the columns for energy and power density. Those are the big ones. They tell you how good it is. Can you see which one came out on top? If you were looking at SC2, you got it. This chart makes it super obvious, right? SC2's energy density, at 22.4 watt-hours per kilogram, it just blows the others out of the water. It's the clear champion of this little showdown. So, what was the secret sauce? The winning recipe was pairing their new carbon material with that stronger 2-molar sulfuric acid electrolyte. That specific acid just worked way better with the unique, porous structure of the carbon, letting it grab onto and then let go of way more energy. All right, but hold on. There's another number here that is just, wow. Get this, 97.8%. So what is that? That's how much of its original storage capacity the winning supercapacitor still had after being charged and discharged 5,000 times. That is some serious durability. I mean, for any energy device you'd want to use in the real world, that kind of stability is absolutely crucial.
Okay, let's zoom out for a second and look at the big picture here. What this all really means. We're talking about turning pollutants into power.
So what's the ultimate takeaway? This research is just a perfect example of a huge idea. We can take something that's a massive pollutant, and with some clever science, we can turn it into a valuable resource. And get this, the process they used is pretty straightforward. It doesn't even need expensive catalysts, which hints that maybe, just maybe, this could be scaled up. It's a win-win, right? A solution that tackles a huge pollution problem and an urgent energy challenge at the same time. And that really leaves us with one last big question to think about. This whole discovery came from looking at the world's most common piece of trash. So it really makes you wonder, doesn't it? What other garbage that we throw away every day could be hiding the next big technological breakthrough?